Hi on there, look what I got here. This is a Teac A-3440 4-channel simul-sync reel-to-reel tape recorder. It's a beautiful piece of equipment that I had for a long time right now in my studio. I don't really use it that much because, nowadays it's all done by computers. But, back in the days this was the best way to record any music. I got this thing for a really good price, and I think it was like 150, 200 euros a long time ago, like 10 years ago, something like that. Then when I got the studio here, I really bought a computer and recorded digitally, really. So this thing was left unused for many years. Yeah, most of the time I don't really do masters on it because I think it's just too noisy. But for recording jam sessions and stuff like that, it's really great because you can actually record hours and hours of tape. So really, this is used just for fun, not really to do professional recording and stuff. So as I said, this is a reel-to-reel recorder. It's obviously quite different from regular cassette. It's composed by 2 reels of tape. Those are enclosed into a cassette, into a plastic container, so you can actually carry this thing, and it's very good. But on reel-to-reel tape recorders, you had this. This is a 10 inches reel of tape. It contains up to 1100 meters of tape, and this is it. This is a really nice new old stock Maxell tape. It's really good. So as you can see, it's very professional. It's made for professional use, and you can actually see this on stereo, the number of tracks. You can actually see the speed of the thing. My reel-to-reel tape recorder here goes up to 7.5 inches per second, which is actually quite fast for a home, a not professional reel-to-reel recorder. 7.5, it was actually pretty fast and really quite good quality. Obviously there were much faster machines, so better quality machines that can actually go 76 centimeters per second, which is blazing fast, but really is quite good. Look at that. Tape selector position, machine, the actual machine you are recording, the engineer, the tracks here, the reference signal here, because you want to have a reference signal for calibrating your machine. So this is a high quality aluminium reel of tape. Obviously there are also some plastic reels. This is a Maxell plastic reel, and you see this hole, and so you need an adapter, which are those blue things here. Those are called nabs, and I used to adapt the tape here, the reel of tape, to a smaller dimension. Usually reels of tape are something like this. It doesn't need an adapter, so you have directly you can actually put this thing directly into here and close it, and that's it. That's ready to go. But obviously the main difference between cassettes and reels of tape is actually the size, the physical size of the tape and the actual reels. But also, as you can see, the tape is actually loose here, so you have to manually insert the tape into your machine. The tape is actually physically much wider. Look at that. This is a 1/4 inch tape, and it's for 4 tracks. So what's the advantage of using a reel-to-reel recording equipment versus cassette players? Well, obviously it's the actual quality you get, because the bigger is the tape, the better will be the quality, and having a reel of physically wider tape contain more information. Also, you get less noise. And another big difference between reel-to-reel recording equipment and normal cassette deck is actually you get 3 heads. So the left one is always the erase head, and this actually is a transducer which puts out a high frequency noise and erases the contents of the tape. The center one is always the record head, and then you have the playback head. You can actually achieve some really quite interesting effects with those type of machines, because you see there is a little gap between the record head and the playback head. So tape physically moves here, and there is a small difference of time that passes from the tape being recorded and being played back. So you can actually loop the sound, so by hearing what is actually recorded and what is actually played back, and you get a delay. So tape delay is actually physically having a gap between the record head and the playback head. Usually there are many playback heads, so you can actually achieve a smaller or wider echo, so a larger amount of time between each repetition. This concept was first developed by Brian Eno and Robert Fripp, which actually invented, in quote mark, the Frippertronics, which used many reel-to-reel recorders to achieve an echo effect. So to feed through the tape, you do something like this. The operation is very simple. You find it the end of the tape, which is usually clear plastic. You feed it through here. This is the tensioner, so you can actually see it has a very smooth action here. So you feed it through the tensioner, through this roller here, then through those pillars. Those little pillars are actually what physically move the tape in and out to actually make contact with the heads. And you can actually see it, this has a mechanism, so you can actually hear the tape while rewinding, because actually gets the tape physically closer to the tape heads. And when you hit play, those are totally retracted, as you can see here. So the tape is actually physically in contact with the heads. So again, the tape goes through here, through this which is called a pinch roller. Back here, this is just a switch, so has a micro switch which senses if there is the tape or not. Sorry, it's a little bit fiddly to do it behind the camera. You feed it through here, you hold it like that, make a nice round, and as you can see, I have the end just here, and then you feed it and make a loop, and now it's actually done. Alright, so it's right about time to disassemble the unit and take a little look inside. So I'm gonna remove the bottom panel here that will actually reveal the all the preamplifiers and the bias control. So let's actually do it. Alright, let's remove it, and as you can see, there are 4 boards, obviously, because there are 4 channels, and each board has its own preamplifier for the microphone input and the amplifier for the recording. So as you can see, it's pretty modular. Let's take this bracket out, and I can slide the boards out here, and here's the board. It's not particularly populated. It's all driven by this 45i8 dual operational amplifier by JSC, obviously, and you can actually find those in modern equipment. For example, I found one. I found the whole amplification, the whole preamplification section on my Teac US 1800 audio interface. They had the exact same chip from Japan Radio Corp. Look at those 2 diodes. Are those germanium diodes? I don't know. They seem so. Like glass germanium diodes. You can actually see the tiny little wire inside. I mean, look at those capacitors here. This is a paper capacitor, and there are a few of them just flying around here. And why they kept the leads so long, I don't know. And it's actually interesting how they marked the can of this inductor Teac. I don't know. And I couldn't find any date code on here. I mean, there are no information on the date it was actually produced. Rec play board, rec play amplifier PCB. I don't know. There is no date code. And as you expect, nothing on the back, all through-hole components, single side board. Alright, so let's actually put this back together and I'll disassemble this. So take a look at that. The board just slides in. Wow, there's nothing here. Just 4 relays, some old school diodes here. Look at those, interesting. So just some relays here, some diodes for the relay coil, obviously will be for protection. Those are, they seem, some jumpers with some there's ceramic coils here. Those are the variable capacitors for the bias adjustment, and yeah, just nothing else. So let's remove the last board here. Oh, that's cute. That's a tiny board. There is nothing written here, so I don't know what is it? Oh, oscillator PCB. So this must be the bias oscillator. Basically, you feed to your tape the high frequency AC signal, basically around from 40 to 150 kilohertz. So it's you can't really hear it, but it will actually rearrange the particles of the metal oxide on your tape and actually improve the quality of the sound. Basically, there is a whole article on Wikipedia. You can actually search it. It's very interesting how it works, and I really suggest you just go and have a look. Basically, this is just an oscillator. You can actually see there are 2 transistors and a big inductor here. And there are some tape machines, tape players and recorders that use DC bias, so they actually apply a direct current, but AC biasing is actually much better. Under here there is another little board, but it's just the headphone amplifier here, and the output selection switch is just that. Alright, so looking on the back, we have all the outputs, all the connectors here. On the bottom here you have all the outputs and the line inputs, and obviously those are all RCA connectors. Alright, you have your remote control for this unit. It's really quite useful. Alright, on the top here you have the AC power in, and then the DBX unit control. DBX are, DBX is a brand. They were very famous and still are for DBX noise reduction system, especially made for tape machines like that. And I think on this one there is a matching DBX unit, which is the 224. I don't really remember, but I think just for the looks of it, with the wooden side panels and all black stuff, is actually matching this particular unit. I don't remember particularly the specification of that unit. I never had a DBX unit, because I don't really record that much with those machines, and nowadays if I gonna record something and I'm gonna just transfer it digitally and remove the noise digitally, it's just more convenient, really. But having a DBX unit, if you go on professional studios, they have those giant tape machines with 24 or 36 tracks, and they have most likely they have a full rack full of DBX units, because you gotta have as many DBX units as the number of your tracks, really. They actually did a wonderful job reducing noise. Alright, so let's actually remove this back panel and take a little peek inside. Alright. So we obviously have the main transformer, which is 125 watts, various voltages, something like 6 different voltages, and you gotta have something like this to run the thing. And not synchronous motors, they are actually driven by some transistors, and as you can see here there is a huge solenoid which retracts, and as you can see actually pulls this little felt ring here, and this will allow the motor to spin. Works as a brake, so the motor spins when you hit play. So when you hit play, this will activate, goes back, retracts, motor spin. When you hit stop, it actually stops also the motor. Alright, on the other motor is actually exactly the same, but you also have a little circuit board, a tiny itty bitty sensor here with a ferrite ring here, so it actually senses the speed of this motor here. On the left here you have your huge capacitor, which I really have to replace because it's now getting quite slow. And this is one of the two motors, main motors. It's a 60 volts, 50-60 hertz, 22 watts. Quite powerful actually. On the back here you have another motor, and this is a 7 watts, 24 volts motor, and it drives a huge flywheel here, which drives the front little pinion of the pinch roller. So this motor here is very important. And speaking of the pinch roller, here is the solenoid which actuates the actual pinch roller. This is it. And this belt here is to drive the counter mechanism. So here's the power supply section. It's just a huge power supply with quite a lot of relays here. And here is a better look at the power supply section. It goes all the way to the bottom of the unit. And those are the 4 boards, one for each channel, for the simul sync mode, and those are EQ boards. And those are all the main power transistors for the thing. And I think I found the driver board. It's all the way on the back here. Maybe it's just for the pitch control. I don't know. And look at those big ass resistors here for the motors. Those actually dissipate quite a lot of power. There is another one here, and just on the side here is the fuse box. Alright, so I'm not gonna take it apart any further because it's quite a mess inside. But in the next video I'm gonna do a recording example with this machine. I'm gonna show you how it's done. So yeah, stay tuned for that. In the meantime, I hope you found it interesting. So yeah, thanks for watching, and you'll see you next time. Bye.